Today we will discuss SN1 and SN2 reactions. SN. Here S stands for substitution and N stands for nucleophilic. That is, it means nucleophilic substitution reaction. This nucleophilic substitution reaction. Now, nucleophilic substitution reaction may take place in various ways. There are different pathways of nucleophilic substitution reaction. Out of those, the two most important are SN1 and SN2, where 1 implies unimolecular and 2 implies, in SN2, 2 implies bimolecular. So the full form of SN1 reaction is unimolecular nucleophilic substitution reaction, and it is written in the reverse order. 1, that is unimolecular, N nucleophilic S substitution reaction. And similarly SN2 reaction, this pathway is called bimolecular nucleophilic substitution reaction. Now pathway means mechanism. Now first we will study the mechanism of SN1 reaction. SN1 reaction pathway. Now why it is called SN1? This SN1 reaction is a two-step reaction in which the first step involves generation of reaction intermediate, which is a carbocation and the second step involves attack of the nucleophile. Nucleophile means the substance which is nucleus loving, that is itself is electron rich. So a negatively charged substance or a neutral molecule having lone pair of electrons with which it can attack any electrophilic center which is electron deficient is a nucleophile. So the second step involves the attack of the nucleophile to the carbocation. Now general reaction is Rx plus nucleophile give R nucleophile plus X minus. So usually Rx is alkyl halide and nucleophile is OH minus aqueous, which leads to the formation of alcohol molecules Now, so for the example is, suppose it is CH3Cl plus aqueous NaOH, it gives CH3OH plus Cl minus. Now, this is a general equation for this alcohol formation from alkyl halide. Now, coming to the detailed mechanism of SN1. Usually, the 3-degree alkyl halides, that is the tertiary alkyl halide, 3-degree alkyl halides undergo SN1 reaction pathway because 3-degree alkyl halides form stable carbocations. For example, CH3 C whole thrice CH3 Br. It will give CH3 whole thrice CH3 plus carbocation and Br minus. So this carbocation is a tertiary carbocation. The tertiary carbocation, and this 3-degree carbocation is highly stable due to the Plassai effect of the 3 methyl groups linked to the carbon carrying the positive charge. Also, it is stabilized by the hyperconjugation effect, which is another electron displacement effect in a covalent bond. Like that of plus I, that is positive inductive effect, due to the presence of 3 cross 3, that is 9 alpha hydrogens. So the carbocation is highly stable, and such alkyl halides undergo SN1 mechanism or SN1 pathway to form alcohols. So this is step 1. Now coming to step 2. In step 2, this alkyl, that is a 3-degree alkyl carbocation, is attacked by the OH minus aqueous. That is, in aqueous solution, NaOH being a strong electrolyte, a strong electrolyte in this case, it furnish OH minus ions completely in aqueous solution, and this OH minus attacks the carbocation to form the corresponding alcohol. So this is the product. This is the 3-degree alcohol which is formed as a result. Now this is a fast step. This step is a fast step, and the first step, that is step 1, which is the ionization step, is a slow step and is reversible. So this is a slow step. We know that the slow step in a reaction is always the rate determining step, that is the RDS. And in the rate equation, only the concentration of the alkyl halide is counted, since the second step is the fast step, and in the first step, which is a slow step, there is no nucleophile. So this is just the ionization of the alkyl halide, and that's why the rate law or the rate equation, in the rate equation there is only the alkyl halide. So the rate is dependent on the concentration of the alkyl halide, and that is why it is a unimolecular reaction. So rate proportional to the concentration of alkyl halide or the substrate. So this is the that is why this is the unimolecular reaction. So this is SN1 reaction mechanism. Now coming to SN2. In SN2 reaction mechanism, only one step is involved. So this is single step reaction. As it is a single step reaction, so rate depends upon that step only. Now we will talk about the rate later on. First, let us see the mechanism. This is the primary alkyl halide. Now primary alkyl halides, we know that primary alkyl halides are form less stable carbocation. So it is unwilling to follow the SN1 mechanism and follows SN2 mechanism. Now here the nucleophile, that is a stronger nucleophile, that is OH minus, is stronger than Br minus. So this is a del positive and del negative charges develops over del positive over the carbon and del negative of the bromine due to the electronegativity of the bromine atom. Now here what happens, this OH minus being a stronger nucleophile, it attacks the del positive carbon atom, and the del negative bromine acquires the entire negative charge and leaves the system. So it is the leaving group, and we get the product, that is the primary alcohol or 1 degree alcohol plus Br minus. Now what happens, this is a single step reaction, so the rate depends upon the concentration of the alkyl halide as well as the nucleophile. So this is bimolecular. It's a bimolecular reaction. That is why this is SN2. This nucleophilic substitution is a bimolecular reaction, whereas the earlier one is a unimolecular reaction.